In chapter 12, section 1, we talked about the basic counting principles, like just the basic fundamentals of probability. We're going to dive a little bit deeper today into what's called permutations. But this is the warm-up for 12.1. So it says the table shows the number of students in your history class. Your teacher chooses one student at random to give an oral report. What's the probability the student is female? So I want to figure out the probability that it's female, right? So female over the entire population from the room. So female, I'm just going to add up the females that are in, God bless you, 9th or 10th grade, which would be 8 plus 6 or 14. And then everybody. So that 14 plus another 16 means there's 30 total in this class. And then simplify it as much as I can. So if I want to leave it as a simplified fraction, it's 7 over 15. That's one way to write it. If it's a decimal, 7 divided by 15, 0.47. If it's a percent, it'd be 47%. So if this was an open-ended question, it would tell you specifically how to leave it, if it's decimal or fractional or percent. If it was multiple choice, obviously you'd be able to see from the answer choices. So this test, which is the last one, thank goodness, is next Thursday, a week from Thursday of this week, so a little bit over a week. All right, question 2 says a bag contains 8 white marbles, 6 red marbles, and 12 blue marbles. Find the odds. So notice this is odds instead of probability. Odds means that we're taking out the top number, so the 2 should add up to the total instead of putting it over the total. But it also says the odds against choosing a white, which means we want the total of everything but white over the amount of white, because that would be what you want to get, what you don't want to get. So if I take the 8 white marbles, that's going to be in the bottom. And then everything else would be 6 and 12, which would be 18. That reduces to 9 over 4. And odds are kept like that. So odds would be 9 to 4, or it would be 9 to 4 this way. Remember, if I take and add those two numbers together, they should give me the total. So 8 plus 6 plus 12. Well, sorry, these should add up to the whole 8 plus 8. 18 plus 8. 8 plus 6 plus 12, plus, which should equal the 18 plus 8, which does. They're both 26. Okay, so again, pay attention to words like odds and probability, because odds is different than probability. And then pay attention to for or against. So if it had said, what's the probability of choosing a white marble, now it would have been flipped. It would have been 4 to 9. Questions on that one? Okay. None. This is the homework. So I'll go through, obviously the odds are in your answer section of your book, but the evens are here as well. I'll go through the evens a little slower. Number 4, which is here, it says, what are the outcomes? It could be heads and heads and heads and tails, tails and heads or tails and tails. Doesn't have to be in that order, but there's 4 total outcomes. Number 10, the probability that you land on an even number would be 6 out of 10, or 3/5, or 0.6 or 60%. So again, any of those formats are good. Number 12 says, what are the odds against stopping on a number less than 12? So I want to know the unfavorable, which is against, which would be stopping on not a number greater than 12, over a number less than 12. So it's 7 to 3, and you can write it as 7 over 3, 7:3, or the word 7 to 3. Number 14 is D. If the odds in favor of the event are 5 to 8, the odds against it would be the reverse, or 8 to 5. Questions on any of those? Okay, oh, that's for number 16. If there's a 40% chance it will rain, what are the odds in favor of the rain? So if it's 40% chance of rain, that would be 4 out of 10 or 2/5. So odds in favor of the rain, it's still the 2, but we do odds now, so we take away that 2 from the 5 to make it 2 to 3. Number 20 was the chart. Okay, it said the first one, what's the probability that a randomly selected female who participated in the survey exercises 2 hours or more each week? So it'd be 161 over 300. It's the females exercising over the total females because it's saying specifically a female student, not just any student. B, what's the probability that a randomly selected 15-year-old student exercises 2 hours? So now we're doing just the 15-year-olds. So from the 15-year-olds who works 2 hours, and that'd be 59 out of 100. And then C, what's the probability that a randomly selected student who participated in the survey exercises 2 hours or more a week? So now we're talking out of everybody, and that's 361 out of 600. Questions on that one? All right. 12.2 is called Probabilities using Permutations. So we're going to take probability and narrow it down into 2 different types between the next 2 sections. This is permutations, and then tomorrow we're going to talk about combinations. Or not tomorrow, Friday, sorry. And then that's what your test is going to cover. 12.1, 2, and 3, that is next week. So we'll start to review this weekend, go over the review on Tuesday, test Thursday of next week. So the basic counting principle says if we're trying to figure out the number of ways that something can happen, and there's like 2 scenarios. If there's an m number of choices for the first one and n number of choices for the second one, then we would figure out how many total possibilities there are by multiplying m times n. So if you look back onto what we did the last section, we said if we were flipping a coin, right, and we wanted to figure out how many combinations of like the coin and the die. So there'd be 2 options for a coin, there'd be 6 options for a die. We could either pair them all up and figure it out, or we would know that 2 times 6 would be 12, and that would be the total amount of ways that you can pair the coin and the die together, the total number of outcomes. So you'll see something like you have 3 shirts and 4 pairs of pants. How many different outfits can you get from there? So you could go the long way, and I could say, okay, I've got 3 shirts. So I have shirt 1, shirt 2, shirt 3. And then I've got pant 1, pant 2, pant 3, and pant 4. And I can wear shirt 1 with pant 1, pant 2, pant 3, pant 4. I can wear shirt 2 with pant 1, pant 2, pant 3, or pant 4. And I can wear shirt 3 with pant 1, pant 2, pant 3, or pant 4. And then I can count all those up. And that's how I can figure out how many there are. The shortcut is figure out how many options there are of the first thing. So if there's 3 shirts, how many options there are of the second thing, there's 4 pants, and just multiply those together. And that's how many ways you can rearrange an outfit. So if you look at the second one that's there, it says there's 6 flavors of ice cream and 3 different cones. Instead of going through each of the different ice creams, pairing them up with each of the different kinds of cones, we would know that 6 times 3 is 18. So there's 18 different ways. That's the basic counting principle. All right, then we start to see things like this, and these are great standardized test questions. It says, in how many ways can you arrange the letters in the word mouse? So M-O-U-S-E, 5 letters, right? It would take a long time, but I could go through and try to figure out all the different ways I could rearrange those letters. Or I can set up a 5-letter space, because that's how many letters there are. And the first space you want to fill, ask yourself how many options are there. So when I go to pick that first letter, how many letters do I have to choose from? There's 5 letters, right? So there's 5 letters to choose from. Thank you. Now I've used one of those letters, right? So when I go to pick the second one, how many options do I have? 4. Used 1, then goes to 3, then goes to 2, then goes to 1. So if I want to know how many different ways, I simply multiply these numbers together. So it's 5 times 4 times 3 times 2 times 1, which is 120 different ways. Which is a lot faster than figuring out all the different ways to rearrange those letters. This is why standardized tests love these questions, because you could probably spend 30 minutes trying to figure out how to rearrange all those numbers, or you could use one simple process like we just did and get the same answer. Yep. Each time. Yeah, but then you would multiply them all together. It's actually called a factorial, which we're going to get to in a second. It has a name. But yeah, so that's how you do it when you start. Now look at B. It's a little different, right? Because B says, in how many ways can you arrange 3 letters of the letters in the word orange? So now you're only filling 3 spots, right? So I only have 1, 2, 3 spots. But in the word orange, you have 1, 2, 3, 4, 5, 6 letters. So when I go to pick the first one, I've got 6 options. But then I've used 1, which means now I have 5 options. And to fill that third letter, I now have 4 options. So we're not going all the way to 1 because we only want 3 letters. So now I get 6 times 5 times 4 are also 120. And that's totally a coincidence that they're the same answer. It's not always 120. Okay. But that's the difference. If it had said 4 letters, I would go 1 more. If it had said 2 letters, I would have gone 1 less. Good so far. Okay. And notice words like arrange, because you're going to see that a lot in permutation. Permutation is arrange, order, all that stuff matters. M-O would be different than O-M when you're trying to arrange the letters. Okay, so we just said it, but a factorial is what it's called when you take a number and you multiply it times itself minus 1 until you hit 1. So a factorial, which actually has the exclamation point, okay? If you said 3 factorial, it's not like you're yelling 3 because you're excited to see it, okay? That means factorial, and that means 3 times 2 times 1. So if you go back to the example we just had, that was mouse, there was 6 letters in it. So if I wanted to figure out how to arrange 6 things, then I would do 6 factorial, which is the same thing as 6 times 5 times 4 times 3 times 2 times 1. Now, scientific calculators have a button that says X factorial. You just got to find it, okay? On a graphing calculator, it's in the probability menu under math. So let me take a picture of it. Okay, so on a graphing calculator, you're going to hit first the math button, and then from there scroll over to where it says probability. And that's where you're going to see the 4th thing down is your little exclamation mark. Scientific calculators also have it. They're probably under a button that says PRB. So Marcella, I think that's yours. Do you have a button that says PRB? Yeah, so if you click there, you'll see the factorial. There's also a couple under things on this menu that we're going to come back to. One is that NPR, so yours has it too. Under that same probability menu, you're going to see that again. So just like remember that's where it is. Most of the things that we're going to use for probability are within those menus. If you don't, so I guess Mateo's not here today, but like if you don't have a scientific calculator and you're using the calculator on your phone, it has a factorial, but it doesn't have the other button, which we're going to talk about in a little bit. So there's an advantage to the graphing and the scientific for sure. The other thing is that's something that you just have to memorize because there's no way to do it without a calculator is 0 factorial is just 1. Because think about it, we always end at 1 no matter what the number is. If 0 is there, you still end at 1. So if you did 0 factorial on your calculator, you would get 1, okay? But there's no way to do that without a calculator. Like I can't multiply 0 times 1 because there's no such thing as something that has 0 things to arrange. So you would always start with 1. Okay, so a permutation, which we just talked about. There's 2 different kinds of of probability once you get into like more specifics, which is permutation and combination. We're going to talk about permutations today. We're going to talk about combinations on Friday. The biggest difference is that permutation, the order matters. So if I have 2 pictures hanging on my wall and I want to figure out how many ways I can arrange them, that's permutation. I can put one in the first spot and one in the second spot, and then I can switch them, and they both count as a different way to arrange them. So that's a permutation. Anything like order or arrange, okay? If you're taking a picture and you want to know how many different ways you can arrange the people in the picture. If you're putting things on a shelf and you're trying to figure out how many different ways you can put things on a shelf, hang things on a wall, anything like that in which order matters, those are called permutations. If it's a total number of permutations, so let's say I have 10 objects, I want to place 10 objects on a shelf, all 10 objects. Then I find the permutation by doing 10 factorial. If I had 24 students and I wanted to figure out how to put each of you in a different seating position in my classroom, and I wanted to figure out how many different ways I could arrange that, it would be 24 factorial. So it would be 24 times 23 times 22 times 21, which is what we just did with the letters in the word mouse, right? We said, how many ways can I arrange these objects, which are now letters? And I would count 1, 2, 3, 4, 5. There's 5 there. And so I would say there are 5 factorial ways to rearrange mouse. And then actually work out the 5 factorial and get the 120, okay? Those are permutations. The second thing here says the number of permutations of n objects at a time. So now let's say I only wanted you to take, if I had 10 items and I only wanted you to put 5 on the shelf. So from that group of 10, how can I arrange 5 of them? And that's where this little formula comes in. Oh, sorry, this is that. This one, take an n. This is what I'm talking about now. So the first thing is your factorial, right? That's if all of the items are used. The second thing is if it's r number of items at a time. So I only want to use the first 3 letters, or I only want to fill 5 of the 10 objects, that kind of thing. And that's this little formula. So if you're building a reference sheet for your test, this definitely needs to go on it, which is n factorial over n minus r factorial. The r is the number of objects you're taking. The n is the total amount of objects. So r will always be less than or equal to n. It can never be bigger than n. I can't have a basket of 10 things and ask you to take, how do you arrange 11 of those 10 things, right? It has to be less than it. So on your calculator, there's also that button. So remember, if I went back to the same menu, the second thing in that menu says NPR. So this is where calculators behave differently. On the newer graphing calculator, if you hit that button, it actually gives you a little space to fill. It looks like this. And it gives you a space to fill the N and a space to fill the R. That's how the newer graphing calculators work. The scientific calculators, when you hit that button, you actually see something that looks like this. The letters actually appear. And to do that, you actually have to put the N in first. So if it was N, 3, 2 like that. On a scientific calculator, you actually have to write 3, then hit the NPR button, and then hit the button that says 2, and then hit equals or enter, okay? So they work a little bit differently, and this is one of the things we've got to practice today. So we'll do an example, and then we'll make sure that your answer is correct. So example 2 says your band has written 12 songs and plans to record 9 of them for a CD. In how many ways can you arrange the songs on the CD? So again, we're looking at the word arrange, and this time it's a certain number of the total. So the total is 12 songs, that's your N. You're trying to pick 9 of the songs, so that's your R. So I'm doing P, N, R, where P is 12 and R is 9. I'm going to do this 2 ways, one with the calculator and one without. Without the calculator, remember P and R is N factorial over N minus R factorial. So this would be 12 factorial over 12 minus 9 factorial. 12 factorial over 3 factorial. Now, one way to do this is take the top number and work it out until you hit the bottom number. So I would go 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 if I wanted to go all the way out, over 3 times 2 times 1. And then the 1s can cancel, the 2s can cancel, and the 3s can cancel. So the shortcuts on this, which this one is not that big of a shortcut, but you'll see it get used a lot later, would be to only do the 12 until you hit the 3 and leave it as 3 factorial, over 3 factorial, and then those cancel, and I'd multiply out these numbers here. So I'd multiply out 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4, and I'd get 7, 9, 8, 3, 3, 6, 0, 0. 79,833,600. It's a lot of ways that you can arrange 9 songs from 12, but that's what it is. If you use your graphing calculator, then you simply go to that menu that is PNR, you hit that button, it's going to give you the little space to put the 12 and the 9, and hit enter, and you get the same answer. If you have a scientific calculator, then you're going to do 12, go to the probability menu, hit the PNR, then hit 9, then hit equals or enter, and you should get the same answer. So everybody, make sure you take the time to check that kind of question on your calculator. Make sure you're comfortable answering it, because obviously those kinds of questions are going to be on your test. And depending on your calculator, the process is different. So you want to make sure you practice whichever calculator you're going to use on your test next week, so that there's no mistakes made by the actual mechanics of the calculator. Questions so far? Okay, example 3. For a town parade, you'll ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. So different scenario, because we're talking probability this time. I have to find out how many ways I could get me first, then the chorus. How many ways is that going to happen? Over the total floats. The total ways, sorry, the total number of ways. The floats can be ordered or arranged. So I'm going to start with that part first. The number of ways the floats can be arranged. We're using all 14 floats. So the number of ways that 14 floats can be arranged, that's your N, right? And we want to know 14 factorial. Taking 2 at a time, because I only want 2. I want to know the first 2. So I'm really doing PNR. So I'm going to go to my calculator. Hang on. Let me go to menu. Math. Probability. PNR. 14. 2. So this would be, I don't know why I put the 14 in the bottom. Ignore that part. I'm doing PNR. Where 14 total rafts floats, but only the first 2 is what I'm looking at. Because I want to fill my spot and the second spot. So this is 182. So there's 182 ways I can fill the first 2 spots in that parade. That's going to go in the bottom. Now the question comes, how many of those are going to involve me going first and the chorus going second? That's only going to happen one way. So it is 1 out of 182 ways. If it had said something like what's the probability of you or the school chorus being first and second, now it's 2 out of 182 because I could go first, school chorus could go second, or school chorus could go first and I could go second. That would make it 2 ways out of the 182. But the way this is worded, where it's your first and the float with the school chorus is second, there's only one way for that to happen. Yep. If it says and, if for something to happen first and something to happen second and there's only one of each, then it's going to be 1 out of whatever the total number of ways are. Does that make sense? But if it said something like you're running a race and you want to know the probability of you finishing in the top 3, let's say, you and your 2 best friends finishing in the top 3, but it doesn't matter if you're first, you're second, or you're third. That's different. If it says what's the probability of you coming in first, your best friend coming in second, and your sister coming in third, that's going to be 1 out of the total number where it would be P and R is now 3. Does that make sense? So if you're welcome. If the order is specific, you're going to do it this way. There's another way to look at this too. So this is the way like my brain sees it, is there's only one way of that, and I do the P and R. The other way to look at it, and so I'm going to teach you both ways, you figure out whatever you want, is that if I remove me and this chorus from the amount that are there, so there's 14 floats total, right? I can put the total number factorial in the bottom, and then I can put what would happen if I took me and the chorus out, and that would be there's 12 left. And you can set it up that way. And so you can do 12 factorial over, this would be 14 times 13 times 12 factorial. The 12 factorials cancel, and I'd get 1 over 14 times 13, which is 182. So either way you look at it, you get the same answer. You just have to figure out which one of those makes the most sense. Go ahead. Brayden, you had a question? Do you have a button that says PRB? So hit that one. Do you see NPR there? Okay, so you have to do it in the order though. You have to type in 14, then you have to hit that button, then you have to hit 2. Okay, so there's one more example like this we're going to do in a second, but just keep that in mind that there's 2 ways to do that. One, figure out what would be the options, and usually there's only one if it's specific that it has to be you and then something else, or 2 specific things in order. There's going to be only one of those options over the total number of ways that you would take the 2 spots out. So that's one way to do it, which I'm going to jump to 4 because that's the same, and then I'll go back to 1, 2, and 3, okay? Number 4 says there are 8 students auditioning for the main role in the school play. The order of the student auditions is chosen at random. Find the probability that you are chosen first and your friend is chosen second. So 8 is the total number, which means 8 is N. We're trying to fill 2 spots, which means R is 2. And because I only want me to be first and Petra to be second, there's only one way to fill that. So I'm going to do 1 over PNR, or 1 over P8, 2. I'm going to go back to my probability menu. So math, probability, NPR, 8, 2, and I get 1 out of 56. And again, the other way to do it is say, okay, I put all of us in the bottom. It'd be 8 factorial in the bottom. In the top, I take out the option that is me and Petra first. So I take out 2 of us, and it would be 6 factorial left. And then it'd be 6 factorial over 8 times 7 times 6 factorial, or 1 over 56. So either way that clicks in your head, whichever way makes the most sense to you, stick with that method. Okay, now I'm going to go back to the ones. I actually think the other ones are easier, right? So number 1 says find the number of ways you can arrange all the letters in the word boundary, and then 3 of the letters in the word. So the first thing I'm going to do is figure out all of the letters. How can I arrange them all? So boundary has 1, 2, 3, 4, 5, 6, 7, 8 letters, which means the first question is 8 factorial. or 56, well, no, 40,320. That's if I use all the letters. And then the second part says just 3 of the letters, which would be P83, or 8 times 7 times 6. Both ways, so you could do it on the calculator, you could do that without the calculator. And you get the same answer. Number 2 says evaluate P63. So again, this could be on a part, like this could be like smaller numbers like that could be on a portion of a test in which you didn't have a calculator. Obviously with where the situation we're in right now, you're going to have your calculator. But let's say that this was on a standardized test. You could actually get a question like that on the portion that doesn't use a calculator. So if it said that, then remember that it would be, it's n factorial over n minus r factorial. So this would be 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial, 6 times 5 times 4 times 3 factorial over 3 factorial. The 3 factorials cancel, and I'd get 6 times 5, which is 30, times 4, which is 120. So that's how I would do it without a calculator, and then obvious with the calculator, just plug that in. Like P149, I'm going to just plug in that way. And that's 7, 2, 6, 4, 8, 5, 7, 6, 0. Definitely not 1. Yes. So that's not 1. If you didn't have a calculator with that one, or you didn't have a if you only had like a 4 function one, you'd have to do 14 over 5, and so you'd have to do 14, 13, 12, 11, 10, 9, 8, 7, 6, 5 factorial over 5 factorial. So you'd have to multiply out all these numbers, which you can do from a calculator. Like I could do that from my phone if I wanted to, but obviously it's a lot easier to use a scientific calculator or a graphing calculator that's got either the factorial, because you could type it in as this, or that has the PNR button. So keep that in mind when you're doing your homework, when you're preparing for the test next week. Whatever calculator you're using for those things, you want to definitely make sure that you get comfortable with, so that it's not the calculator that hangs you up. Yeah? The factorial. Where it says what? Yeah. Yeah. Sure. The only reason I would say to make sure you know how to do it both ways is because you could get a question like, again, it's not going to happen next week because of where we're at. But if I was to give a test on probability in a class, I could give you part of a test without a calculator, and then part of a test with it. So just make sure you know how to do both. But because we're in the scenario that we're in and you can use your calculator, I would certainly take advantage of it. You're welcome. All right, questions on any of the notes for today? So I know this is new to you, so it might be a little bit tricky, but it's going to get trickier when we start to bring in combinations, because the wording on things change and you have to figure out if it's a combination or a permutation. That's where it gets a little bit tricky. So you definitely want to master this stuff before we talk again on Thursday. What is today? Yeah, on Thursday. Because then we'll start to do the combinations, which is a little bit different. Does anybody have questions on their project? I did know a couple of you turned them in, but the time is dwindling. So obviously you want to make sure that you're working on that. They are due Friday. Everybody's good? No questions on the project? If you haven't started at all, my advice is to get to it, folks. You don't want to be doing that late at night. And then if you have a question and you're asking me like, you know, Thursday at 10 p.m., it's going to get ignored. So just be prepared for that. Yes. The reason I say to do it in centimeters is because if you measure in inches and you're dealing with an eighth and a fourth and all that stuff, it gets so sloppy. But if you measure with the centimeters, each tick mark is a tenth. So if it's like 3 and goes past it to the second tick mark, it's 3.2. So it should be a lot easier to measure. Everybody else is good? All right, I'm going to let you head out a couple minutes early.